In this lecture, I'm going to now describe what a triple bond would look like, and a triple bond is going to have one sigma and two pi bonds. Remember, the first bond is always a sigma bond, and for an example, I've picked this N2 molecule, which is the nitrogen gas that has a triple bond in it. So one nitrogen atom has an electronic configuration of 1s2, 2s2, 2px1, 2py1, and 2pz1. So if you look at the outermost shell of a nitrogen atom, it has three orbitals that need electrons. So an electron is going to be attracted into the 2px orbital, and an electron would be attracted into the 2py orbital because they're not filled completely, and an electron from another atom is going to be attracted into the 2pz orbital. So three orbitals of nitrogen are going to try and attract electrons. So if there are two nitrogen atoms, they're going to attract each other's electrons. They're going to end up forming covalent bonds, one of which is going to be a sigma bond and the other one is going to be a pi bond. So let's start with the 2px orbital first. So I've drawn a nitrogen atom. I've not drawn all the orbitals. Let's just focus on the 2px orbital first. So the green one that I've drawn over here is the 2px orbital. So I'm shading the green orbital just to highlight it. So the green orbitals are the 2px orbital, and the 2px orbital has both of the nitrogen atoms have just one electron in the 2px orbital. So this nitrogen atom on the right is going to try and attract an electron from the other nitrogen atom's 2px orbital, and the other nitrogen is going to try and do the same. It's going to try and attract the others. So they're both basically attracting each other's electrons. Now the electrons are being pulled to the right and to the left, but they would not be able to go to either side. They're going to get stuck in the middle because both of the nitrogen atoms are going to try and attract these electrons. So the electrons, the highest probability of finding an electron would be in the middle, because those electrons are going to get stuck in place and they're going to end up forming a sigma bond. So the 2px orbitals, they will merge, and the region of highest electron density would be right in the middle. So the dark region in the middle, that's where there's going to be a very high probability of finding an electron, but because the electrons would not be able to go to either side, and they're going to end up forming a sigma bond in the middle. Now moving on, let's look at the second orbital now, the one in blue. So you have the 2py orbital, which is drawn in blue over here, and let me shade the 2py orbital. So the 2py orbitals also need one electron. This nitrogen needs one electron in its 2py orbital because it only has one electron. It needs another electron. The other nitrogen, exactly the same case, it also has just one electron in the 2py orbital. And exactly the same thing is going to happen. They're going to start attracting each other's electrons. This 2py orbital is going to attract the nitrogen atom on the right hand side. It's going to attract the 2py orbital electrons from the other nitrogen atom, and they're both going to do the same. They're going to attract each other's electrons, and the electrons are going to be pulled towards the middle because both nitrogen atoms are attracting each other's electrons. So the new bonding orbital, or the new region of highest electron density, would be right in the middle somewhere. So the electrons would be attracted, and the region of highest electron density would be right in the middle. And the same is going to happen to the other lobe of the p orbitals. They will attract each other's electrons, and the region of highest electron density would be right in the middle. So the 2py orbitals are going to merge. They're both being attracted by both nitrogen atoms. So they're going to get stuck in the middle somewhere. So they're going to end up forming a pi bond. Now the third p orbital, which is the 2pz orbital, and remember it's on the z axis. So I've drawn the pz orbital in red. So the one in the red, which I'm shading right now, that's the That's the pz orbital, and think of it as coming out of the page and going into the page because it's on the x-axis. So this orbital is lying on the x-axis, is 90 degrees to all the other orbitals. So, but they are also in parallel. So this one, imagine it as coming out of the page and going into the page. So it's going to overlap. They're both going to attract each other's electrons. This one, this nitrogen atom is going to attract the electrons from the other pz orbital, whereas the first nitrogen is going to attract electrons from the second nitrogen atom, its pz orbital, and they're going to attract each other's electrons, and they're going to merge as well. So the merging would look something like this, and the region of highest electron density would be over here in the middle, because when the two orbitals merge, both are trying to attract each other's electrons, so the electrons are going to get stuck in the middle, and that's going to happen with the other lobe of the pz orbital as well. So they're going to merge as well. So I'm going to shade the merging on the other side as well, and the region of highest electron density would be in the middle. So there are going to be two pi bonds being formed, one by the blue orbitals, the one which is 2py, and one by the 2pz orbital, which are shown in red over here. And the px orbital is going to end up forming a sigma bond. So there's going to be one sigma bond, and there are going to be two pi bonds formed when two nitrogen atoms bonded together. So remember, whenever two elements bond, the first bond is the sigma bond. Electron density lies exactly in the middle, while the rest of the bonds are going to be pi bonds, because once the middle area is occupied, now electrons would either overlap above the axis or below the axis or to the side of the axis. So remember, the two pi bonds are lying in opposite planes. The red ones are coming out of the page and going into the page. The blue ones are on top and below, and the green orbitals are merging together in the middle.